Hello there guys, and welcome to our next class for the third unit. Teacher Krishna here, and just like you know, this is a class that is part of Beehive School and 8th BYS. Our subject is science, and we are working on week number 26 today. So be welcomed, and let's go over our presentation for today. Remember to have your notebook with you in order to make today's summary. Just like every week, make sure to include the date, ending mind, title, the summary itself, and some additional decoration in the notes that you take in your notebook. Here you have the ending mind. Identify the major air masses, the main types of fronts, and cyclones and anticyclones. Okay? Now let's go with a summary of activities. You need to watch this video and make a summary, of course, and read lesson number 4, pages 132 to 139 and complement your summary. Complete the exercises from the previous pages, and once you are done, participate in the Zoom session. Okay? Those are the activities for today. So let's go ahead and start with our topic right now. So we're going to talk about air masses. And right over here you have a small picture of the world. And just you can notice right over here, we have like different delimitations around the map. So these delimitations are pretty much masses of air that have been put together according to their pressure. So just to give you a small spoiler of what we are going to talk about, if mass of air has a high pressure, usually that's going to be together. Or if it has a low pressure, it's going to be together as well as with the same temperature. Usually, cold masses of air are going to be put together as well as warm masses of air. And depending on what section of Earth we analyze, we are going to have a different type of air mass. So we have cyclones and tornadoes are spinning storm systems, but tornadoes are way smaller than cyclones. So cyclones and tornadoes form because of the combination of different air masses. But tornadoes, remember, that are small, just like the ones that we can have right here in Guatemala. And cyclones are huge, but they are very big. And we have the definition for air mass. It is a large body of air in the lower atmosphere. There are 4 main types. So this is very important. Make sure to take notes of the 4 main types of air masses. We have maritime tropical, continental tropical, maritime polar, and continental polar. Okay? Now let's talk a little bit more about each one of them. So you have the types of air masses here. Let's start talking about the tropical one. They form in the tropics and have a very low air pressure due to their warm temperature. So, very important. We have a warm air mass, and of course they have a low pressure. Now let's talk about polar. And they form either at 50 degrees north or south. Their temperature is cold and have a high air pressure. So pretty much this one is different to the one that we were seeing before. So tropical and polar are opposites, because tropicals are warm and of course they have a low air pressure, while polar air masses have a cold temperature as well as high air pressure. We have maritime. They form above oceans and the air is humid. So since they are exposed to a very large portion of water, that's why the air will be humid, because a lot of water will be evaporated, and at the end it is going to put it to the atmosphere. And lastly, we have the continental ones. They form above large portions of land, and they are not exposed to large portions of water, so they are less humid. So pretty much this one will be the opposite of maritime. So continentals, they can form in any continent, just like the name says. It can be in Africa, in Europe, in America. But since they don't have a lot of exposure to big water portions such as the ocean, then the humidity in these air masses is going to be very low. Okay, now how air masses move, and this is something very important. And I'm pretty sure that you have heard that sometimes a cold front is coming to Quetzaltenango or a cold front is entering Guatemala. So what does that actually mean? So basically a cold front is like, let's say it is a big portion of air mass with a cold temperature. So that's why when a cold front enters the country or enters our department, then the whole land is going to be very cold. So when air mass move and it interacts with the region, it can cause the weather to change. So not only the temperature in a certain location is going to change, but actually the weather itself can change. So we have different types of fronts. Right over here we have the prevailing westerlies. There are major wind belts that move from the U.S. Usually they move from west to east. We also have jet streams. They are groups of winds that move at a high speed. They form at an altitude of 10 kilometers. They carry air masses from east to west. So, and right over here we have an example of different air masses. Right over here on the right we have a air mass with warm air, and right over here we have a cold front, or an air mass with a cold temperature. So jet streams are the ones that are going to move these air masses from one place to another. And we have fronts, large portions of air with different pressure that collide over continents or oceans. One more time, this is one example of cold front. We have two different air masses, one with a cold temperature and one with a warm temperature. So my question is, what are the main types of fronts? In total, they are 4. Here we have 2 examples of the fronts that we were talking about. We have a cold front and we have a warm front. Let's go over each one of them so we can have more information. First of all, we have a cold front, and they move along the ground, so they arrive very quickly. Warm air rises while cold air stays close to the ground, which causes the temperature to decrease. So let's suppose that we have one section of cold air and one section with warm air. So cold air, since it has a higher air pressure, it is going to stay to the ground. So whenever it collides with the mass of hot air, what's going to happen is that the hot air is going to start going up, while the cold air stays on the ground. So most likely the temperature is going to decrease when one of these cold fronts arrives to a certain location. But what happens to the opposite? What happens with the warm front? So a huge mass of warm air arrives slowly because it interacts with the cold air. It rises and generates clouds. The weather stays cloudy and rainy when it arrives. So now we have the opposite. Now the mass of a hot air is going to be way more dominant and way bigger than the one of cold air. But the problem is that, one more time, warm air has a lower pressure, so it usually tends to go up, right? But what happens here is that since it is dominant, it is going to start moving the mass of cold air. So it is going to take a little bit longer to arrive in there, and some of the changes that it can generate in the weather could be rain and clouds for a little period of time. Right? And what are the other 2 types of fronts? We have the stationary front and occluded front. So let's start with the occluded front. 2 masses of cold air trap a mass of warm air between them. It causes the temperature to decrease. Rain or snow can be generated. So first of all, we have 2 masses of cold air. Cold air here and cold air here. And right in the middle, we are going to have the mass of warm air. But the thing is that it cannot be mobilized since it is trapped inside of the cold air, okay? So what's going to happen is that the most drastic weather conditions are going to be generated in here. Because we already mentioned that air masses with a very cold temperature usually tend to be on the ground. And what happens to the masses of warm air is that when they cool down, they are going to generate clouds, rain, and in this case, snow can be generated. So it is very cold on the ground, and it is going to start to rain or to produce snow, which is part of the extreme conditions of the weather. And lastly, let's go with the stationary fronts. So two masses of air meet, a cold one and a warm one, but neither of them mixes and can generate clouds and rain. So in this case, the fronts are not going to mix among each other. So we are going to have one part of cold air and one part of hot air. But instead of mixing, they're just going to be passing among each other. So one next to the other. But since they are not mixing, then not extreme conditions or like very tough weather variations are going to be generated in there. But some clouds and rain can be appearing in there. Okay, guys, so that'll be about it for today's lesson. Thank you for coming. And make sure to go back to the activities section. And of course, to read the last 2 pages of our activity today to complete the summary in your notebook. And that'll be about it. And I will see you guys in a couple of minutes during the live session. Goodbye and always take care.